Section number 42 is entitled Parallel and Perpendicular Lines. Parallel and perpendicular lines. The symbol for parallel is two parallel lines. And the symbol for perpendicular is that symbol. Perpendicular lines are lines that cross at a right angle. It has to be a right angle. Those lines are perpendicular. These two lines, they cross at a right angle. They're perpendicular. These two lines are not perpendicular because this is not a right angle. If you want to see it a bit more clearly, hope it's clear that that's not a right angle. If that's not a right angle, then this can't be, because these two add up to 180. And if this is not 90, well then this can't be 90. Because 90 plus, let this symbol represent not 90. If you have 90 and you don't add 90, you know what? You don't get 180. But this is 180. Okay, those are not perpendicular. They really, really have to meet at right angles. And when I drew something like this, and I said this is a right angle, well then they all are. Right angle means 90 degrees. If this is 180, and I'm telling you this piece is 90, if I tell you this is 90, well then this is 90. And you know what? This is 180. And if this piece is 90, then that must be 90. And this piece is 180. If this angle is 90, then that must also be 90. The four angles are 90. If this is 90, well then that angle is 90, and this angle is 90, and that angle is 90. So all four 90 degrees. Think about that. Okay. So now, I'm going to give you information about two lines, and I want you to decide if they're parallel or perpendicular. And in order to do so, you need to know the rules. Two lines are parallel if, one, the two lines have the same slope. Two lines are parallel if the two lines have the same slope, or two, both slopes are undefined. Now this is the definition that's normally found in algebra textbooks. Two lines are parallel if the two lines have the same slope. Well, if this is one line, call it line 1, it has a slope. Now, if line 2 happens to be right on top of it, then line 2 has the same slope. They're the same line. One line has one slope. So we know that the slope of line 1 is equal to the slope of line 2. Read the very top line. Two lines are parallel if the two slopes are the same. two lines have the same slopes. So this means, by definition, if the slope of line 1 equals the slope of line 2, that means line 1 is parallel to line 2. Now I know when I was a student in elementary school, my teacher would hammer into us, parallel lines never meet. Parallel lines never meet. Well, I take it my school teacher never studied basic algebra, because I have two parallel lines, line 1 and line 2, and they meet in a lot of places. They intersect here and here, here and here and here. They intersect all over the place. Some students would say incorrectly, oh, they intersect everywhere. Nonsense. I mean, come on. They didn't intersect here. They didn't intersect here. You just didn't finish the expression. Yes, they intersect everywhere on the line. They intersect everywhere on line 1. Or you could say they intersect, line 1 and line 2 intersect everywhere on line 2. They're the same line. Parallel lines can intersect. But if they do, they're the same line. Two parallel lines can definitely intersect. But then they have to be the same line. Now let's talk about perpendicular lines. Two lines are perpendicular if one, the product of their slopes is -1. If the product of their slopes is -1, or one slope is 0 and one is undefined. One slope is 0 and the other slope is undefined. One slope is 0, the other slope is undefined. Now, what is this undefined slope? Well, a slope is the change in y over the change in x. And if it's undefined, I didn't say indeterminate, I said undefined, that's when the bottom is 0 and the top is not 0. The change in x is 0. Between the 2 points, you don't go left or right any, and the change in y is not 0. That is, if here is one point, to get to the other point, it can't be here, because then you went some to the left and up some. It can't be here, because you went to the right and up some. It can't be down here, because you went to the left and down some. But you can't go to the left any. It can't be here, because then you went to the right and down. But you can't go down. I mean, you can't go to the right. That is, if you're here, the other point can either be above or below. You just go up. That means for the change in y over the change in x. Since you went up some, the change in y is not 0. You went up to here. But since you didn't go left or right any, it's 0 for change in x. That's undefined. Even if you went down some, but you didn't go left or right, you get a vertical line when it's undefined. And when it's horizontal, the slope is 0. But a vertical line and a horizontal line, they are perpendicular. If the slope is 0, that means it's the horizontal line. Slope is 0, it means horizontal. If it's undefined, it means vertical. And a horizontal and a vertical line, they are perpendicular. Most probably, if I asked you to draw two lines that were if I asked you to draw two lines where one line was perpendicular to the other, you would probably draw a horizontal and a vertical. Okay, but nonetheless, there's two ways for two lines to be perpendicular. If you multiply their slopes, you get -1, or one slope is 0 and the other one is undefined. Those are the two ways to have lines that are perpendicular. So I'm going to give you some information about two lines, and I'm going to ask you if the two lines are perpendicular or parallel. I'm going to tell you line 1 contains 2 points and line 2 contains these other 2 points. I'm going to ask you if they're parallel or perpendicular or neither. Lines don't have to be one or the other. Given those 2 points and say these 2 points. Alright. Okay, remember, 2 points determine a line. So when I tell you line 1 determines those 2 points, that nails down line 1. And if I tell you I tell you 2 points on line 2 are, that nails down what line 2 is. So basically, we just compute the slopes. We compute the slopes of line 1. If y goes from 7 to 9, remember the slope is the change in y of the change in x. And y goes from 7 to 9, it went up 2. And if x's go from 3 to 5, went up 2. And 2 over 2 is 1. Okay, we have the slope of line 1. Just knowing what that slope is doesn't help us out at all to know if the lines are parallel or not, or perpendicular. We must have both slopes. Okay, the slope of line 2. Y goes from 5 to 11. It went up 6. X went from 4 to 10. It went up 6. 6 over 6 is 1. Now that I have these two slopes, I look at them. Since they're equal, that implies that line 1 is parallel to line 2. 1 equals 1. 1 equals 1. So line 1 and line 2 are parallel because they have the same slope. Okay, I'm going to give you the same type of information for a second set of lines. I'm going to give you 2 points on each of them. And we're going to determine if they are parallel, perpendicular, or possibly neither. Line 1 contains -2, 5, and 4, -1. And line 2 will contain, what's a good one? 4, 5, hold on 1 second. Okay. 3, 8, 2, 1. So, what is the slope of line 1? What's the change in y? You go from -5 to -1. So you're at -5, and now you're at -1. And you can count it. -4, -3, -2, -1. 1, 2, 3, 4. You went up 4. If you go from 2 to 4, you did not, -2 to 4, you did not go up 2. I mean, after all, from 2 to 4 is 2. So from negative 2 to 4 is not also 2. It's going to be 6. If you just say hello to 0, it becomes obvious. Negative 2 to 0 is 2, and 0 to 4 is 4. 2 plus 4 is 6. So you went up 6. And positive over positive is positive, and 4 over 6 is 2/3. So we're done. We found the slope of line number 2. Excuse me, line number 1. Now we play the same exact game for line number 2. Let's find the slope of line 2. From 8 to 1. Went down 7. That's the change in y. You went down 7. And from 3 to 2, you went down 1 for the change in x. Negative over negative is negative. Excuse me, is positive, which you don't have to write. And 7 over 1 is 7. These slopes are not equal, so they're not parallel. The lines are not parallel. And that product is not negative 1. I mean, the sign won't even be negative. A positive 2/3 times a positive 7 will be positive. Even if you don't know positive y, it's positive. No positive number is negative 1. It isn't like, come on, positive 2,418 1/3. Come on, that's negative 1. We all know that. So let's make sure this product is not 2,418 1/3. Nonsense. No positive number is equal to negative 1. So the answer, I don't know why the n didn't come up. But here the answer is neither. The two lines are neither parallel nor perpendicular. Okay, how about line 1 contains negative 4, negative 7, and negative 1, negative 4, and line 2 happens to contain negative 3, 7, and negative 1, 4. Let us find the slope of line 1. If you go from negative 7 to negative 4, negative 7 to negative 4, there's 0. You went up 3. Negative 6, negative 5, negative 4. Negative 6, negative 5, negative 4. You went up 3. Okay? If you go from negative 4 to negative 1, from negative 4 to negative 1, negative 3, negative 2, negative 1. If the numbers are close to one another, you can count them out. You went to the right 3. So the slope is 1. Divide the same two numbers, get 1. What is the slope of line number 2? Well, you go from 7 to 4. You're on the 7th floor of the elevator or of the building, and you take the elevator down to the 4th floor. You went down 3. 6, 5, 4. You went down 3. And the change in x. How about we let this be instead negative 4? How about we let that be negative 4? So the change in x. You go from negative 4 to negative 1. Negative 3, negative 2, negative 1. You went up 3. Positive over negative is negative. 3 over 3 is 1. Okay. These two numbers are not equal. Therefore, line 1 is not parallel to line 2. But you know what? If you were to multiply those two numbers, you'll get negative 1. Since one slope times the other slope is negative 1, that implies line 1 is perpendicular to line 2. given 2 points and you computed the slope of line 1 was 2/3 and the slope of line 2 was negative 3/2. Well, if you multiply these, 2/3 times negative 3/2, the first number is positive, the second number is negative. A positive times a negative is a negative. Now, ignore signs. The first number, I'm just looking at it as if it's 2/3, and the second number as if it were 3/2. No more signs. Well, the 3's cancel out, the 2's cancel out to 1, -1. This would imply that line 1 is perpendicular to line 2. If the product of the slopes is -1, one way of doing, now, when is a product -1? Well, when is a product 1? If you take any number and you multiply it by its reciprocal, well, you're going to get on top AB and on the bottom BA. But that's 1. I don't know why the A didn't come up, sorry. That's 1. And if I make the signs different, if I leave this A as positive, but I make that negative, then the answer will be -1. If you flip 1 over, A over B, and you change your sign, that product will be -1. That's another way. Negative reciprocals. Try a couple more. Compute the 2 slopes, and that's it. And look at their results. Suppose I tell you line 1 contains 3/4 and 7/4. And I tell you line 2, it contains 2/1 and 2/3. Well, the slope of line 1 is the change in y, well, there is none, and the change in x from 3 to 7 is up 4. So it's 0. And the slope of line 2, well, from 1 to 3, the change in y is +2. But the change in x, there is none. And 2/0 is undefined. Well, if one slope is 0 and one slope is undefined, that implies that the 2 lines are perpendicular. That was one of the definitions of 2 lines being perpendicular. If one slope is 0 of a line and the slope of the other line is undefined, the lines are perpendicular. You have to know your definitions, and there it is, statement number 2. 2 lines are perpendicular if condition 2 says one slope is 0 and the other slope is undefined. Okay, that completes the section on parallel and perpendicular lines. Know the 2 definitions. And yes, parallel lines can intersect.